So we will see next problem, tutorial 3 example 4.6. So this is the example from the textbook. So the planes x is equal to 2 and y equal to minus 3 respectively carry charges 10 nanocoulomb per meter square, okay, and 15 nanocoulomb per meter square respectively. Anyway, if the line x is equal to 0, z equal to 2 also carries the charge of 10 pi nanocoulomb per meter, calculate the electric field at 1, 1, minus 1 due to the 3 charge distribution. So first we will see what is the picture. This is your x-axis, this is your y-axis, this is your z-axis. Okay. Now let's see what is the x is equal to 2 is a plane. That means this is at x is equal to 2, you can have a plane, and this is a very big plane, it's saying. So this is the plane. So this is a big plane which is at x is equal to 2, and there is another plane which is at y is equal to minus 3. So y is minus 3, so where it is like here. So let's say this is y equal to minus 3. So there is another plane which I will show by different color. Okay, this is another plane. This is another plane. Now there is also a line at x is equal to 0 and z equal to 2. So this is the point z equal to 2, and we want at x is equal to 0. So x is equal to 0 means y can be any value, and it is at z equal to 2. So this is a line which is at z equal to 2. Let me check the question again. Is it at, yeah, it is at z equal to 2. So this is the line charge. Now this line charge is having the charge density rho L, which is given as 10 pi nanocoulomb per meter, and we have the other one like the second plate. That means at y is equal to minus 3, the charge density is rho S, 15 nanocoulomb per meter square, and the other one which is having the charge density at x is equal to 2, which is nothing but it is 10 nanocoulomb per meter square. Now we have a point which is given here. The point is 1, 1, minus 1. So x is equal to 1, y equal to 1, and z equal to minus 1. So z equal to minus 1 means we have to go down in this direction. So there is a point here, let's say some point here. Okay, this is behind that plate which is shown in orange color. So there is a point which is 1, 1, minus 1. So 1, 1, minus 1. So at this point, what will be the electric field intensity? So that's what the question. Okay, so that's what the question. Now we know that if we have an infinite sheet of charge, then the electric field will be in this direction, which is the direction of the normal to that plate, and it is given as the charge density divided by 2 into epsilon 0. So now you know the electric field due to this guy. That means the plate number, I will label it the plate number or the sheet number 1. This is the plate or the sheet number 2, and this is the line which is given as 3. Okay, so this is the part 1, 2, and this is 3. Okay, now due to 1, so this is the electric field intensity due to the sheet of charge. Similarly, we have for the line charge. If you have a line charge, suppose rho is the perpendicular distance, you see, you should observe this should be 90 degrees, then the electric field will be in this direction, and this will be the direction of rho. So the electric field is given as rho L divided by 2 pi, where rho L is the charge density, and here rho S is the surface charge density, and here is the line charge density, 2 pi epsilon 0 divided by rho, and the direction is given as a rho. Now if we know this, then we can find what is the electric field due to the first part. Okay, that means the plate number 1. So you can see that the electric field due to the plate number 1, and the plate number 1 is situated at x is equal to 2. So the plate number 1 is situated at x is equal to 2. So this is your plate, and your point is like this is y, this is z, and your point is somewhere here at 1 1. So your point is somewhere here 1 1 and z equal to -1. So I think I have to redraw that point correctly. Yes, I need to change it from here, it's not here. So it will be here somewhere at x is equal to 1, y is equal to 1 and z equal to -1. So the point will be here 1 1 -1. So anyway, if we are seeing from if we are seeing on the screen, then this 1 1 -1 the point 1 1 -1 will be behind the plate number 1. So you can see that the plate number 1 will be having the electric field like this, and it is given as E1 and it is normal to the plane. So this will be the direction of the electric field will be, you see this is the AX direction. So the direction of the electric field will be minus AX direction. So electric field we can find for the plate number 1, electric field is given as, I will use the same color which I have used for the plate number 1. So the electric field is given as rho s 1 divided by 2 epsilon 0 into minus AX. You see, because it is towards minus AX. So this is equal to, what is the charge density? It is given as 10 nanocoulomb. So 10 into 10 power minus 9, okay, into minus AX divided by 2 into epsilon. What is epsilon? Epsilon 0 is 10 power minus 9 divided by 36 pi, okay, 36 pi. So you will get this answer as minus 180 pi into AX. Okay. Now we will see what is the electric field due to the plate number 2. So the plate number 2, I have used the color blue color, so I will use the same color. So this is the plate number 2, and it is having the charge density 15 nanocoulomb per meter square. Now you see the plate number 2 is on the y axis, y is equal to -2. So this is your y axis and the direction is AY, and this is your x axis, is the direction AX, and this is your z axis and the direction is AZ. So this guy will be contributing along the y axis. So the electric field will be rho S2 divided by 2 epsilon 0, and the direction will be AY. Okay, and you should note that it is independent of the distance, because that we have already discussed in the previous videos. So you see here that E2 is equal to rho S2, that means 15 nanocoulomb, that means 15 into 10 power minus 9 into 2 into epsilon 0 is 10 power minus 9 by 36 pi into AY. We will get it as 270 pi into AY. Okay. So now next we have to see what is the electric field due to the line charge. Okay, line charge, I have used the red color, so I will show it in the next page, that's better. So you have z axis, you have x axis, you have y axis, and this is the point 1 1 -1, and this is the line which is going through z equal to 2, okay, and x is equal to 0, x is equal to 0. So x is equal to 0 and z equal to 2, and y can be any value, because it is a line, y can be any value. Okay, so I will write it in the order, that's better to avoid the confusion. So this will be x is equal to 0, okay, then y can be any value and z equal to 2. Now we want to find the perpendicular distance because electric field will be acting like this. So we have to find what is this distance, perpendicular distance. So we know the position vector here, and we know this vector. What will be this one? You see here the y is equal to 1. So at this point also y equal to 1. Okay. Then already we have seen on the line x is equal to 0 and z is equal to 2. So we can find what is this distance vector. Let's say this distance vector is d. Okay. So the distance vector. So d is given as, okay, d is given as, you can see this is my final point because I am considering the electric field in this direction. So my distance vector d is given as, my final point is 1 minus 0 into ax plus 1 minus 1 into ay plus minus 1 minus 2 into az. So my distance vector is ax minus 3 az. Okay. Now I want to find the direction of my rho. So this is my distance vector. So the magnitude of this distance vector will give you what is the distance. So the magnitude of the distance vector is nothing but the rho. So that is the rho. And what will be my a rho? A rho is nothing but d, the distance vector divided by the magnitude of distance vector. Okay. So this is equal to ax minus 3 az divided by the magnitude of that is 1 square plus 3 square. I think 1 square plus 3 square, it is root 10. Okay. So I will get it as root 10. Okay. 1 square plus 3 square. Now we can find what is the electric field E3 due to the line charge, which is given as what is the formula? Sorry for this, actually I don't remember the formulas. The line charge I have seen, yeah, rho L into a rho by 2 pi epsilon 0. Okay. So it will be like rho L into rho L divided by 2 pi epsilon 0 into rho into a rho. Okay. So this become, what is rho L in the question? It is given, the rho L is given as, the value of rho L is 10 pi nanocoulomb per meter. So 10 pi nano into 10 power minus 9 divided by 2 pi. What is epsilon 0? It is 10 power minus 9 divided by 36 pi. Okay, 36 pi into a rho. What is a rho? Ax minus 3 az. So first of all we need to find what is the distance, the magnitude of this. So the magnitude of d bar we have already seen, it is nothing but root of 1 square plus minus 3 square. This is equal to root 10. So it's easy. So into root 10, then what is my a rho? The direction, it is x minus 3 az, x minus 3 az divided by root 10. Okay. Now I can cancel out some terms. Pi, this become 18. Okay. Then this will cancel. Then this, if I multiply, this become 10. Okay. So I can change this to 10. So what I will be getting? So if when I do the calculation, I will be getting this as, you can see above there is, this become root 10 into root 10 is 10. So that 10 and the 10 above here will cancel. So I can write it like this will cancel. So this become 18 pi multiplied with ax minus 3 az. So I got E1, E2 and E3. So I can find the total field. Total electric field is nothing but E1 plus E2 plus E3. So this is nothing but, we have seen first one, how much? E1, I think E1 we got it as we have E1 is equal to minus 180 pi, then E2 is equal to 270 pi into AY. So minus 180 pi into AX plus 270 pi into AY, plus you see this one will be 18 pi into AX minus 18 into 3, it is 54 pi into minus 54 pi into AZ. So you will get the total as minus 162 pi into AX plus 270 pi into AY. If you add these, then minus 54 pi into AZ. So this will be my electric field intensity at that point. I hope this is clear to you. Thank you.